Hello everyone, I am Abhishek Srikant Patil, working in Computer Science Department, Srimati Gigi Khadse College, Muktinagar. In this video, we are going to learn about what are data structures, what is the need of data structures, and what are different types of data structures. So let's begin. What is a data structure? A data structure is data organization, management, and storage that enables efficient access and modification. Different data structures are suited for different problems. Some data structures are useful for simple, general problems such as retrieving of data that has been stored with specific identifier. For example, an online dictionary can be structured so that it can retrieve the definition of a word. On the other hand, specialized data structures have been devised to solve complex problems. Need of data structure. Data structure is fundamentals in computer science. Computer deals with manipulation of various kind of data, where from the concept of data structure comes. Data structure is required for following tasks. Storage representation of user data. User data should be stored in such a way that the computer can understand it. Retrieval of storage data. This data should be retrieved in such a way that user can understand the data. Transformation of user data. Number of operations can be performed on user data so that it can be transformed into some other form. Example, let's consider two ways of organizing the data in dictionary. The data in dictionary is organized, suppose randomly. Then to search a person by name, one has to linearly start from the first till the last name in the dictionary. If the data is organized by in a sorted way, that is in alphabetical order, then the search is much easier. Instead of sequential search, we may search in a particular area. Because of organizing data in sorted order, search is much faster. Hence, we can conclude that there is a strong relationship between structuring of data and operations to process the data. Advantages of data structures. The first advantage of data structures is it can be used to manipulate and access the information on the computer. Various operations can be performed on data structures. Data structures are used to improve the program efficiency, and they also improve the memory utilization or the storage. Types of data structures. Data structures are divided into various types, such as primitive and non-primitive data structure, linear and non-linear data structure, static and dynamic data structure, persistent and ephemeral data structure. If we see the figure, we could understand that various types of data structures have been displayed over here. Data structure basically is divided into primitive and non-primitive. In primitive data structures, we have integers, floats, characters, and booleans. While in non-primitive data structure, the data structure is further divided into linear and non-linear. In linear data structure, we have arrays, linked list, stack, and queues, while in non-linear, we have trees and graphs. Let's see what are primitive, non-primitive, linear, non-linear data structures. A primitive data structure, it is a set of atomic or primitive elements which do not involve any other elements as its subparts. For example, the data structure defined for basic built-in data types like integer, float, character, etc. Non-primitive data structure, it is set of derived elements such as arrays, files, linked lists, etc. Array data structure of C consists of set of similar type of elements. File data structure of C consists of different types of elements. Hence, array structure, files, and user-defined data types are non-primitive data structures. Linear data structure. A linear data structure can be defined as a data structure where elements form a sequence or maintain an order. Every data element has a unique successor and a unique predecessor. Non-linear data structure. Data structures are used to represent the data containing hierarchical or network relationship between elements. Every data element may have more than one predecessor as well as successor. In this type of data structure, the elements do not form a sequence. Static and dynamic data structures. A static data structure, if variables are defined inside a function, then its value is kept till the function executes. We say that the variable is local to the function. When the function execution is complete, the storage allocated for the variable is freed. The variable have static or dynamic lifetime. In static, the memory is allocated at the beginning of the program execution and freed only after the program terminates. Array is an example of static data structure. In dynamic lifetime, memory is allocated for the variable dynamically, means it is created and destroyed during the execution of program. In C, library functions like malloc, calloc, alloc are used for dynamic allocation of memory. A data structure which is created at runtime is called as dynamic data structure. Linked list, trees, and graphs are examples of dynamic data structures. Persistent and ephemeral data structures. A data structure that supports operation on most of the recent version as well as the previous version is called as persistent data structures. While an ephemeral data structure is which supports operation only on the most recent versions of the data. Data structures in languages like C, C++, Java, Pascal are ephemeral data structures. For example, pushing element on stack modifies the stack pointer. Insertion or deletion into the linked list changes the list. Data structures in functional programming languages like Lisp are persistent. Insertion into the list creates a new list and old version is still available. Thus, in this video, we have seen what are data structures, why there is need of data structures, and which are different types of data structures. In the next video, we should learn some further things about algorithms and data structures. Thank you.